In this video, we're going to talk about how to find limits from tables or from an equation like you see here. This one says the limit as x approaches 2 of this function. And the first thing you always try is just plugging in 2, because sometimes when you plug in the number, that's just the limit. But in this case, if you plug in 2, you get 2 cubed minus 4 times 2 over 2 times 2 minus 4. And what happens is you get 0 over 0 if you plug in 2. And this is known as indeterminate form. And this is going to come up in future videos as well. But since it's coming up here, we'll just go ahead and say it. This is called indeterminate form. Which means literally we can't determine what the limit is because we get 0 over 0. It's also telling us that this function is undefined when x equals 2. In order to find the limit for this, we can use tables. In the last videos you looked at graphs, but starting in this video we'll look at some tables. We'll set up this table, x, and then this function, x cubed minus 4x over 2x minus 4. And we're just going to plug in some values and see what the function's equal to. So we know if we plug in 2, the function is undefined. But what we want to do is plug in numbers very close to it on either side and see if the function or the graph comes in to some specific number as it gets closer and closer to 2 from both sides. So we're going to plug in some numbers close to 2 that get closer and closer to 2. So like 1.999 is very close to 2. 1.99 is a little bit further away because it's 1.990. And 1.9 is even further away, that's 1.900. And onward. So that's coming in from the left side. If you think about how the number line works, how graphs work, this is really coming in from the left. And we're also going to come in from the right. So we'll start further away, like 2.1, get a little closer, 2.01, get really close, 2.001. And I'm sure you're already thinking this, but you can keep getting closer and closer. You could put 2.0001 and just keep adding zeros. And you'll eventually get closer and closer to what the actual limit is. And of course, coming in from 2.1 towards 2, this is coming in from the right side. From the right. And my writing isn't great, but there you go. From the right. Instead of wasting your time, I went ahead and I plugged in all these numbers on my own to my calculator to this function, and I'll just go ahead and write them here for you. But picture I would have plugged in 1.9 to all these x's, 1.99 to all these x's, and so on. The result of plugging all those in was like this. And as it looks like when you plug in 1.9, 1.99, and so on, as you get closer and closer to 2, these numbers get very, very close to 4, and I would imagine if we plugged in even closer numbers, we'd get even closer to 4. The same thing's happening as you're coming in from the right side. You plug in 2.1, you get 4.3, 2.01, 4.03, 2.001, 4.003, and from the right side, it's also coming in closer and closer to 4. And like I said, if you put in like just an estimate. Maybe we put in 2.0001. It's even closer, like 4.001 or something like that. And so we can probably reasonably assume that the limit as x approaches 2 of this function, x cubed minus 4x over 2x minus 4, is equal to 4. Here's the next type of problem you might encounter. It'll say, what is a reasonable estimate for the limit as x approaches 1 of g of x? And it doesn't actually tell us what the function is, but it did just name it g of x. So we'll assume this is some function, and we don't know the full equation, but it's called g of x. So they are already telling us, okay, what's the limit as x approaches 1 of g of x? If you plug in 1, you get 2,000. That's interesting. So if you evaluated this function, you said, what's g of 1? What is the function value at x equals 1? The correct answer would be 2,000. However, this is not the limit. Let me write that over here. This is not the limit as x approaches 1 of g of x. It's g of 1 equals 2,000. It's not the limit as x approaches 1 of g of x. We have to look closer at the data to know what the limit is. So as we approach 1, what does the value of the function seem to go towards? Well, as we come in from the left side, going this way, 389, 393, 399. And as we come in from the right side, it's 409, 403, 399. So this is really interesting. If you plug in 1 to this equation, we don't know what it is, but you'll get 2,000. But as you get closer and closer to 1, it looks like this function is approaching maybe 400 from both sides, maybe 399. So let's just go ahead and say the limit as x approaches 1 of g of x, and we always write it in this format. The limit as x approaches a number, and we have to show the function as well, is equal to, let's say it's 399. It could be 400. In order to tell, we'd have to plug in some like closer numbers over here, and maybe get closer to 400. But since it looks like it's only heading to 399, we'll just say the limit is the limit as x approaches 1 of g of x is 399. However, g of 1 is equal to 2,000. But this is what the question is asking for. Let's look at some one-sided limits. Let's try to find the limit as x approaches -3 from the left side of t of x. This function is called t of x. And let's try to find the limit as x approaches -3 from the right side of t of x. Always labeling this function as t of x, or whatever it's called. So let's try to find the limit as x approaches -3 from the left side. And I'll write that down here. So that's this little negative sign up top means from the left on the number line. It's like this symbol right here from the left side. Or we can find it from the right side as well, and that's this plus sign. So just from the left and just from the right. So coming from the left side, heading towards -3. It says 2.578 when you plug in -3.1, 2.589 when you plug in -3.05, and so on. And it looks like it's getting closer and closer to 2.6, and at -3 it's actually 2.6. So coming in from the left side, it looks like it's going to head towards 2.6. Now what happens when we come in from the right side? It says when you plug in -2.9, you get 4.79. Then you'll get 4.85, 4.99, and then it just jumps to 2.6. So coming from the right side, it actually looks like it's heading toward 5. And it doesn't really matter what's happening at -3. When you're determining the limit, you don't care about what's happening at that specific number. You're just thinking about what happens as you're getting closer and closer to that number. So from the left side, it makes sense. Yeah, it's heading toward 2.6, then it becomes 2.6. From the right side, even though it goes up, it looks like it's going toward 5, and that's why we can say the limit is 5. However, when these two things are not equal to each other, so this is something very, very, very important. If the left-hand limit and the right-hand limit don't agree, if the left-hand limit and right-hand limit don't agree, and I'm shortening this here for you, if the left-hand limit and right don't agree, there is no overall limit. So we would say a normal limit, like limit as x approaches -3, and since it doesn't have a symbol up here, it means from both sides, so just coming in from the left and the right, we would say this limit does not exist. This limit does not exist because the left-hand limit is going to 2.6, the right-hand limit's going to 5. Since they don't match, the overall limit, x approaches -3 in general, does not exist.